Okay students, the topic for discussion is subroutine. A subroutine is a group of instructions called a subprogram that will be used repeatedly in different locations of the program. Whenever we want to use a set of instructions so many times in a program, we can define these set of instructions as a subroutine. So subroutine will be a collection of instructions, a set of instructions. Rather than repeat the same instructions several times, they can be grouped into a subroutine that can be called from different locations in a program. So in assembly language, a subroutine can exist anywhere in the code. However, it is customary to place subroutines separately from the main program. And to implement subroutine, we need two instructions. These are call and return instruction. Basically, to implement a subroutine, call instruction will be used to call that subroutine. So call instruction is used to redirect program execution to the subroutine. So we can call the subroutine with the help of call instruction. And once the program execution transferred to that particular subroutine, and after the execution of that subroutine, the control of program execution will return to the calling program with the help of return instruction. So return instruction is used to return the execution to the calling routine or program. So basically we can use a set of instruction so many times or at different locations in a program. And we need two instructions. One is call, second is return, to implement subroutines. So let's have a look on a sample program to implement a subroutine. Suppose the program is written into a memory location from 2000 up to 2400. And at this location, a call for subroutine that is written on 2070. So once this instruction occurs, the control will transfer to 2070, which is the starting address of the subroutine. And then subroutine will start executing. Then it will get the return at 207F. The return instruction will return the control execution here, 2043. After the call instruction, transfer the control of program to the next instruction after the call instruction. So at 2040 location, the control will transfer to 2070, and after executing the subroutine, the control from location 207F will go back to the next instruction written at 2043, which is the written after call instruction. And the call instruction, call 2070, is 3-byte instruction. So that's why it written on at 2040, 2041 and 2042. So here the control will transfer to 2070, and from this point the control of program will transfer to 2043. So during the subroutine execution, once the call instruction will occur, so this address will be stored onto the stack, so that whenever it returns from the subroutine, this address can be found. So this is the view. Here 2042, the subroutine will be called, the subroutine is written over 2070, and the execution of subroutine will start at 207F. The return instruction is found, then it will return the control of program execution to the next instruction at 2043, which is written after the call instruction. So what happens when a call instruction occur in the program? So suppose we take an example of call 400H instruction. It is a 3-byte instruction. So when a call instruction is fetched, the microprocessor knows that the next two memory locations contain 16-bit subroutine address in the memory. This is the address of subroutine. So at this location, this instruction has been fetched, and now control will move to this location. After execution, it will return to this location. So how would it know whether I have to return this address? So whenever this call occurs, the value of program counter always stores the address of next instruction. So at this location, the address of next instruction 2003 will be in program counter, and this value will be stored onto stack with the help of push instruction. So as we know, the push insertion into the stack will always happen in pair. So first the stack pointer will decrement, the starting value will be copied, and then stack pointer will decrement, and the next value will be copied. So the value of program counter will be stored in stack. Whenever and this now program have to transfer at this location, so this value will be copied into W and Z register, which are temporary register and internal register of 8085, and these register are used for internal purpose. So these two register will hold the value of this location, and the program counter value will be stored onto the stack, and then this value, which is stored in WZ, will be moved to program counter as a next instruction to be executed, which is the address of subroutine. So whenever a call instruction occurs, the processor knows I have to move to this location. So this address will be copied into WZ register, and the value of program counter will be moved to stack. The value stored in WZ will be moved to program counter as the next instruction to be executed as the starting address of subroutine. The control of a program execution will be transferred to the subroutine. So once the subroutine has been executed, now the return instruction will occur at the end of subroutine. And whenever return instruction occurs, it retrieves the microprocessor retrieves the return address from the top of the stack so that it get to know where to transfer the control of the program execution. And the value of the program counter we have stored on to the top of the stack, and then this value will be loaded into the program counter, and this will be the value of calling next instruction in the calling program. Here the stack we stored the value of 2003 into the stack. So at the occurrence of a return instruction, this return address will be stored into the PC as a next instruction address. So this is all about how call and return instructions implement subroutine. So subroutine, we group a set of instruction into a subroutine so that we can use those instructions repeatedly at different locations. And two instructions are used. One is call and second is return to implement the subroutines. And whenever the call instruction will occur in the program, the processor will store the program counter value onto the stack and the address of the subroutine into WZ pair of register. Then the WZ pair content will be moved to program counter as the starting address of subroutine. That control will transfer to the subroutine. Once the subroutine will be executed, the return address will transfer the control to the next instruction in the calling program. So the address of next instruction will be fetched out from the stack and will be loaded into the program counter. So that's it about subroutine implementation in 8085.